Fable 5 just solved a maths problem that was basically impossible to crack for 87 years. It's called the Jacobian Conjecture. Imagine an infinite 3D complex space. You can move every point anywhere new, but you can only use addition, subtraction, or multiplication. So only polynomial equations to build this entire system, called a polynomial map. At any single point, you can zoom in and check something called the Jacobian Determinant. Think of it as a local stretch factor that tells you whether the space around a point gets stretched, squeezed, or crushed flat, so that nearby points become impossible to tell apart. Now, suppose that number comes out to a constant non-zero value at every single point in the entire space. No matter where you zoom in, nothing ever gets flattened. Does that guarantee the whole transformation is globally reversible? That every final point came from exactly one starting point? Or could two completely different starting points still end up in the exact same place, even though everything looks perfectly fine up close? That's the core of the Jacobian conjecture. For 87 years, mathematicians believed the answer was yes. They tried to prove that if your polynomial equations followed those rules, the space would always be reversible. Nobody could prove it or disprove it. Then came Fable. Researchers gave it the problem, let it reason from first principles, and it found something nobody was expecting: a polynomial map with a Jacobian determinant of -2, where a single endpoint could be traced back to 3 different starting points instead of 1. First posted by Levent, the result still needs peer review. But if it holds up, Fable just settled one of the biggest problems in mathematics. The funny part, you can even talk to Claude about it and watch it lose its mind.